Hello everyone, welcome back to the channel. So today we are going to talk about segment trees. When do we use segment trees, right? Problem first approach. What problems does segment tree solve? What is a segment tree and how is it actually implemented? So let's first take a very simple example. Let's say that I have an array nums. These are the indexes and these are the values which are at these specific indexes, right? Let's say I have three queries, query number 1, query number 2 and query number 3. Query number 1 says that I need to calculate the sum of this particular interval or this particular range of the array. Query 2 says that I need to calculate the sum of this particular interval, and query 3 says that I need to calculate uh, the sum of the interval 0 to 4. So what's the most easiest way to do this? What's the brute force approach? The brute force approach is that I use a for loop. I start from the starting index and I iterate to the ending index and I calculate what the sum is, right? So these are just three queries. Just imagine if I have 10k queries and the size of my array is, let's say, 1 million numbers. Okay, in that scenario, what would be my time complexity? You see, for the brute force approach, the time complexity is very clearly O of n. Why? Because in the worst case, I will have to iterate the whole array for every query, right? A user can ask me to calculate the sum of 0 to n in each query, isn't it? Now, a very simple solution exists that whenever I calculate the sum of two specific two distinct integers, I sort of store them in a map or in a set, something like that, so that when the user asks me the same query again, I can rather than again processing it and calculating it, I return the answer from the map. But then, what if the situation is something like this? The user asks me 0 to n, then he asked me 0 to n minus 1, then he asked me 1 to n, then he asked me 1 to n minus 1. So these are all different queries, but then approximately they take O of n, like they require me to traverse the whole array, right? So in the worst case, it's going to be O of 10k into 1 million, which is probably going to give me a time limit exceeded error. Why? Because 10k is 10 to the power 3, 1 million is 10 to the power 6, which gives me 10 to the power 9 operations. If I'm doing 10 to the power 8 operations, usually that's acceptable. But this is clearly way beyond what 10 to the power 8 is, right? So a simple solution of doing this, of calculating the sum, interval sum or range sum, is that you utilize the prefix sum concept, right? Let me write that down. The prefix sum concept. How that works is something like this. So the first number is 5 and then you keep on adding each and every subsequent number. So 5 plus 6 is 11, plus 4 is 15, plus 2 is 17, plus 3 is 20, 21 and 23. So what this does is basically it makes calculating the sum of, previously it was taking me O of n. Now after a little pre-processing, it's going to take me O of 1 actually. How exactly? Let's see. Sum of 2 comma 5, sum of 2 comma 5. How can I calculate that? I can calculate that very easily. You see, I calculate the sum up and until 5. What is it? It's 20. And what is the sum up and until 1? It's 5. If I subtract these both, what do I get? I get 15. Let's see if the answer actually is 15. 4 plus 2 is 5, and no, I'm getting the wrong answer. Why am I getting the wrong answer? Because this was index 4. Wait, why am I getting the wrong answer? I'm getting the wrong answer because 5 plus 6 is 11 plus 4 is 15. Why am I getting the wrong answer? I should get the right answer, right? uh I should do 20 minus 11. Sorry, I should do 20 minus 11, right? So do 20 minus 11. When I do 20 minus 11, what do I get? I get 9. So is the sum of all of these numbers 9? Let's see. 4 plus 2 is 6. 6 plus 3 is sorry, wait, I'm calculating the sum of 2 comma 5, right? Yeah, 6 and then 9 and then 10. Then it's wrong. Did I calculate the sum correctly? 5 plus 6 is 11. Am I doing wrong? Wait, let me start again. So I want to calculate the sum of 2 comma 5, right, which is this particular part of my array. I'm going to see what is the sum till this point, till 5. 11, 15, 17, 20, and then 21. Okay, that's actually index 6 in this scenario. Why? Because I started from index 0. At index 0, the sum is 0, and I'll tell you the reason later on. Right now, let just be as it is. So what I'll do is I'll calculate the sum till index number 6, and then now again, the sum till index number 6 means that I have all of these numbers inside of my range. Now I have the sum of all of these numbers. If I just exit these two numbers, which is 11, isn't it? If I calculate the sum till this point and I subtract it, so what will I be left with as a result? I'll be left with this portion only. I calculated the sum for the whole part, and then I took this part and eradicated it. So what am I left with? I am left with only this particular series, right? So what did I just do? I simply did prefix sum of 5 plus 1. So you can say n plus 1 minus prefix sum of start, right? Prefix sum of start. This thing gives me the range sum in just O of one time, isn't it? Now, why do I start from 0? Let me tell you the reason. For example, let's say that I wanted the sum of not 1 comma 6, I wanted the sum of 0 comma 6. So you see, we are, or for a moment, let's just say I did not start from index 0. Let's say I did not start from index 0. I actually started from index, this was my index 0. Okay. So my prefix sum array, this is my prefix sum array, and it at index 0 it says 5. What if the query now says that you need to calculate the sum of 0 to 3, right? 0 to 3. What's the sum of 0 to 3? It's 5, 6, 4, 2. And the thing is, how am I going to calculate that? How am I going to calculate that?